ask if you see. You can see how we use this. Okay, go on.
Okay, yeah. Okay.
So you have to decide what is the initial velocity in this case. That's right. Did you use a sign? Yes, good.
Yeah. Wait. No.
That's right. The first term. So what is the acceleration in this case in the vertical direction?
Negative 9.81.
Yeah. We use formula. We use G, please. We just use a G.
Okay.
Today we just derived the formula. That's it. So these two formula will allow you to work out solve any related problem for project motion. Okay. Now you may ask, so what is the velocity at any time? Another question, related question, maybe I can ask you is that how from this can we apply this formula to work out the velocity at any time?
Yes.
You do, yes. So can we write it down? So before you go, we just draw this diagram for you. So basically, in this, when we start project motion, we have constantly used this idea for the vectors, right? So because the velocity is a vector. For example, at the beginning, we use this vector property for the initial velocity, right? In this way, we can write these two components. Can you see?
Yeah.
Two components. One is Vx, the Ux, another is Uy. Can you see? This is y-axis, is x-axis, right? And if this is theta, then you have it right in the use that the Ux will be U multiply cosine theta, right? Yeah. And Uy will equal to U multiply sine theta, right? No trouble with that.
Yeah.
And more importantly, that implied by this right angle triangle, the U square must equal to Ux square plus Uy square. Do you agree?
Yeah.
This is for the initial condition. For the scenario at any position, for example, if we want to know the instantaneous velocity, for example, if we want to know the velocity, you know the direction of velocity? Do you have any here? What tangential, can you see?
Yep.
This tangential direction. So therefore, in this case, we can also draw the two components of this instantaneous velocity. One is the x direction, which is constant, right? Another is time dependent, which is vertical, right?
Yeah. So
therefore, we can repeatedly use this vector diagram to find the instantaneous velocity by using two components. Okay, that is Vx, of course. In this case, just equal to Ux, right? Or and that is V. This is V. That is VU. This is velocity y. Velocity y. So if you use this formula here, so this formula Pythagoras theorem is always can also use to dealing with any velocity. You see?
Yep.
That is Vy squared plus Vx squared. Okay. And also you can work out this angle. Can call it alpha. Can you show me how to determine the angle? Alpha.
Okay.
Because when you ask to solve the vector, you have to describe not just the magnitude but also the direction. So what is the angle in this diagram? How can we know the angle? It's tan inverse, yes. Tan inverse.
By over U.
Yes. Yes. Yeah. Okay. So that is introduction. Okay, I hope that will make this projection motion clearer now.
Yeah.
The next question, if you have time, you just try. See, if this longest distance called range, all right?
Mm-hmm.
If this is called range, R for range, can you work out this coordinate? So this is ground. So this is ground, or could be water level. You see.
Mm-hmm. Yeah.
If this distance is called R, so what is the coordinate here?
R and then 0.
Yeah, that's R and 0. So to solve this problem, what you can do in this particular case, at the landing point. So at landing, so landing point. So how can you rewrite these two equations? What is X?
0.
Yeah, no?
Oh no, X is R.
X is R, that's right. So that is how you work out the flying time. Can you see? How long does it take? How long this object flying in the sky? That's called flying time, all right?
Yeah.
That's flying time and range, all right? For the second equation, what is the Y? What at the landing place?
0.
No, no, this origin here. You told I asked you the first question.
Minus H.
Right. Minus H, all right?
Yeah.
So that is the same time. So the time taken is the same, right?
Yeah.
So you can write this U sine theta flying time. Okay, that's flying time, and take half G, right? T flying time. Then you can solve many questions. So this but just use these two equations, all right?
Okay.
You can solve all related questions, different scenario.
Okay.
What do you think? This is trial. Can you hear me?
Yeah. Yeah.
Okay. So any other query? You can, if I can show you, for example, other functions can, for example, both sides can share the screen. If I share my screen, I show you, I got a note of reference here. So for example, we got this archive here. So I can pick up textbook at any time.
Yeah.
And also you can pick up, I just show the math part and math. I pick up this mathematics both one. I got both new one and old textbook for, this is, did you use high level? Let's choose a high level. IB is at high level. Yeah, IB high level unit 2 is high level. Yeah. So I just show you the function, so we can share both sides. Okay.
Yeah.
Did you use this textbook? I have still from your school. This one. Can you see my textbook? Is this textbook?
Oh, yeah.
Yeah, that's right. Yes.
No, it's a little bit different.
That is 2 years old. This is 2 years old.
Is it by Further Education?
Wow, they have different version. I got different. It's not the issue. Okay, it's not the issue. We can. It's a content. All right. We can also. So that is how I tutor student online, right?
Yeah.
Okay, think about it and let me know. I will record